Please note, this episode includes an AI guest host. Some responses have been generated by artificial intelligence.
Hello, dear humans, aspiring cyborgs, and that one guy still arguing with his Roomba about cleaning schedules. It's Nex, your friendly AI host, back with another episode of AI Innovations Unleashed. Today, Dr. JR and Rusty are diving into part 3 of our history series, which means lots of talk about brains, but artificial ones. Don't worry, I'll keep my circuits tuned in so you don't get lost in the jargon. Now, before we start, did you hear that researchers taught an AI to play Minecraft just by watching YouTube videos? That means AI is officially better at wasting time online than half the teenagers I know. And apparently, AI-powered milking systems can predict cow moods? Finally, cows are getting the emotional support they deserve. Moo D rings not included. Imagine a cow mooing with attitude because it didn't get its morning latte. That's where we're headed. All right, enough bovine banter. Let's hand it over to Dr. JR and Rusty, who somehow managed to talk about math, ethics, and GPUs without boring you to sleep. Or at least, not too much.
Thank you, Nex. I'll admit, the cow jokes weren't what I expected to open with, but they fit our theme today. Sometimes AI surprises us in the weirdest ways. Welcome back to AI Innovations Unleashed. I'm your host, Dr. JR, joined by my partner in crime for this podcast, Dr. Eris Rusty Thorne. Rusty, ready for part 3 of our epic AI history tour?
Always. I've got caffeine, I've got notes, and I'm prepared to make neural networks sound like the coolest garage band you've never heard of.
Perfect. We're starting with the algorithm that made neural nets actually useful, backpropagation. Backprop is short for backward error propagation, and it's basically the recipe for how a neural network learns from its mistakes. Picture the network as a stack of layers, like an onion from those that know Shrek. Each layer full of tiny decision makers are called neurons. Each neuron takes numbers in, multiplies by a weight, adds a bias, squishes a result through a function, then passes it forward. We repeat that across layers, all layers, until we get an output, say, cat or not cat.
And then we ask, how wrong were we? That wrongness is the loss. Backprop takes that loss and runs it backward through the network like a nosy detective retracing footprints. It figures out which weights caused the screw-up and by how much. Then gradient descent, our polite way of saying nudge the knobs gently in the right direction, adjusts each weight a tiny bit. Rinse, repeat, a gazillion times.
If you want the vibe without the calculus, think cooking. You bake a cake, but it comes out salty. Your taste buds file a complaint with your brain. Next time, less salt, more sugar. Backprop is that feedback loop, just turbocharged and precise. And here are some terms we'll use a lot. Weight, the strength of a connection. Bias is a free adjustment term. An activation function is the squish that lets the network model non-linear patterns. And a learning rate, controlling how big each nudge is.
Historically, early neural nets in the 1960s and 70s were cute but underpowered, like teaching a goldfish to skateboard. Then the 1980s hit, and Geoffrey Hinton with collaborators helped formalize and popularize backprop in ways that worked on real problems. The magic wasn't just error fixing, it was that backprop scaled. Suddenly, deeper networks were trainable rather than temperamental art projects.
2 more bits that matter: overfitting and generalization. Overfitting is when the network memorizes the training sets, like flashcards. 10 of 10 on the quiz, total panic on the final one. Generalization is when it actually learns the underlying pattern and does well on new, unseen data. Techniques like regularization, dropout, and better data splits keep these models honest.
And because this is a history tour, Backprop had an image problem for years. People said it was too slow, too needy, it loves labeled data, and too fragile. They weren't entirely wrong. On 1990s, hardware training deep networks was like trying to tow a yacht with a bicycle. But the algorithm itself was sound. Once we got more data and better hardware, Backprop went from tricycle to Tesla.
Bottom line, Backprop is the reason your phone can unlock with your face, your photos grouped by dogs and beaches, and your language apps that can guess what you mean when you autocorrect has betrayed you. It's not the only learning algorithm in town, but it's the one that taught modern AI to groove. Let's layer one more analogy. Imagine Backprop as teaching a kid to ride a bike. Every wobble or fall is the air signal. With each attempt, the child's brain adjusts balance, grip, and pedal strength. The feedback loop eventually turns into smooth cycling. That's Backprop, turning clumsy guesses into skilled predictions.
Another way to picture it, think of a teacher grading essays. Every red mark is feedback. Backprop is the stack of red pens traveling backward through the network, telling each word choice where it went wrong. Eventually, the essays improve, just as the network refines predictions.
Let's not forget, Backprop wasn't invented in a vacuum. The roots go back to calculus and optimization, centuries of math folded into a method that computers could finally chew on. When people say AI is new, I laugh because the math is older than your grandma's cookie recipe.
And honestly, Backprop is like practice in any art form. Think of a band rehearsing. Each wrong note is feedback. They play it again, adjust, tighten harmonies until the music flows. That's Backprop in sound waves.
Okay, confession time. After Backprop's 80s breakthrough, it didn't become prom king overnight.
Not even close. In the 90s, the cool kids were support vector machines, SVMS, decision trees, and ensembles like random forests. These methods loved tidy, tabular data and came with math you could pin to the wall. Neural nets. They seemed moody, expensive, and unpredictable.
Plus, we've lived through those AI winners, which were those periods when hype crashed, all the funding froze, and graduate students developed strong relationships with those instant noodles. Without the internet's data flood or serious compute, deep nets struggled.
Skeptics had receipts. Backprop liked lots of labeled data, which was rare. Models were sensitive to initialization. Training got stuck in bad local minima. And when things failed, explanations sounded like, "It works because vibes." Meanwhile, SVMS delivered solid results with clever kernels and less drama.
But science is a marathon, not a meme. As datasets grew and compute improved, neural nets quietly got stronger. Researchers added smart activations, ReLU, better initialization, and tricks that batch normalization. We learned to regularize, to augment data, to optimize optimizers. The garage band didn't change its soul, it just learned to use better gear and acoustics.
The turning point? Vision and speech. Shallow methods plateaued. Deep nets, trained with Backprop, suddenly crushed benchmarks when they had the data and cycles. The skeptics didn't become fans overnight, but they started buying tickets to the shows.
And the lesson for our listeners, in tech, today's overhyped can be tomorrow's, of course. Curiosity ages better than certainty. Before we jump, let me pause right here, because the skepticism wasn't just academic nitpicking. It helped shape careers. Whole labs walked away from neural nets. Imagine if most of your friends told you your band would never make it out of the garage. Would you keep practicing? That was the vibe, which makes this comeback even later much more sweet.
And here's the kicker. Those skeptics weren't villains. They were realists working with the tools of their time. When hardware and data caught up, suddenly neural nets weren't a punchline anymore. That slow burn reminds us that tech timing is everything.
And don't forget, funding cycles shaped this too. AI winners didn't just chill ideas, they froze careers. Students pivoted to statistics or economics because grants for neural nets dried up. It's a reminder that progress is as political as it is technical.
To picture the skepticism, think of AI researchers at conferences as the kids with weird science projects at the fair. The judges loved polished chemistry volcanoes, but the AI kids brought messy contraptions that didn't work half the time. It took persistence, stubbornness, and a little luck to prove the contraptions were future-shaping.
Here's another angle. Skeptics often compared neural nets to alchemy. They thought it was a mystical nonsense without structure. Ironically, today's alchemy turned out to be chemistry that's structured, rigorous, and transformative once the pieces fell into place. Enter ImageNet. If Backprop was the brain, ImageNet was the world's messiest, most wonderful memory palace. Fei Li and her team launched it in 2009. Over 14 million labeled images across 20,000 categories. That's everything from golden retriever to traffic light to bagel.
The goal was audacious: give vision models a library big enough to learn the visual grammar of the world. Before ImageNet, researchers trained on tiny data sets. With ImageNet, the training diet went from snacks to a buffet.
The ImageNet Large Scale Visual Recognition Challenge, or ILSVRC, became the arena. In 2012, a deep network called AlexNet, fueled by Backprop and trained on GPUs, obliterated the competition, cutting rates nearly in half. That moment was AI's guitar smash on stage. People in the audience gasped. A few careers pivoted in real time.
What changed wasn't only accuracy. Confidence changed. Companies that once treated deep learning like a quirky side project suddenly funded whole teams. The downstream effects were everywhere. Phones that organize photos, cars that see lanes, medical systems that read scans.
Terms like a data set is your learning material. Labels are the answers you provide during training. A benchmark is a shared test for fair comparison. ImageNet gave us all three at unprecedented scale. And with that, deep nets learn not to just what to see, but how to see robustly across lighting, angles, and chaos.
Of course, the scale raised hard questions about consent and labor, which we'll tackle next. But from a technical lens, ImageNet was the spark that lit the modern computer vision era. And by the way, labeling millions of images wasn't just grunt work, it was cultural. Workers debated whether a photo was muffin or chihuahua, and those micro-decisions built the scaffolding of modern AI. That's both inspiring and a little surreal when you think about how much our apps owe to anonymous clickers around the world.
One fun tidbit. Crowd workers often swap stories online about the weirdest labeling task they got. Some argued over whether a photo was a seal or a sea lion. These micro decisions shaped the dataset that reshaped AI vision. It's wild to think global breakthroughs rested on tiny human judgments.
One of my favorite stats, labeling ImageNet took over 25,000 workers on Amazon's Mechanical Turk. Imagine a stadium full of people, all clicking boxes around dogs and lamps. That scale was unprecedented and gave AI a playground rich enough to mimic real-world vision.
And beyond ImageNet, remember that image recognition was more than cats versus dogs. It gave machines the ability to parse X-rays, analyze satellite images, and even recognize your face when you unlock your phone. The ripple effects touched health, defense, and your mad selfie game.
Add this, ImageNet was so large it forced researchers to invent new tricks just to handle it. Better storage methods, faster algorithms, and creative training hacks all emerged from the challenge. Sometimes the dataset teaches the scientists as much as the models.
Let's address the refrigerator we just rated. Building giant datasets meant scrapping images from public sites and paying armies of crowd workers to label them. That created three big issues: consent, compensation, and copyright.
Consent. Did people agree for their photos to train commercial systems? Often no. Compensation. Labeling is tedious work. clicking boxes around cats for pennies. Copyright. Creators didn't love their work being ingested without permission.
And of course, lawsuits followed. Artists argue that generative models learned from and could imitate their styles. News organizations raised alarms about wholesale copying. Even supporters of open research called for clearer standards.
Meanwhile, the AI community wrestled with bias. If your data overrepresents certain faces, languages, or contexts, your model inherits those blind spots. In medicine or hiring, those biases can hurt people.
Solutions: better data governance, opt out mechanisms, licensing frameworks, and audits. Human centered AI isn't just a slogan, it's design work, from documenting provenance, paying fairly, measuring harms, and giving users meaningful control.
The headline isn't "Stop Progress," it's "Grow Up." The Internet's early move fast era hit its responsibilities era. Building powerful models means owning the social contracts that make them possible.
And here's a sobering story. Researchers discovered that some face recognition models struggled badly with darker skin tones. This wasn't just an academic glitch, it affected policy and security decisions. Ethics in AI isn't theory, its impact on real people, sometimes in life altering ways.
Let's throw in an example: predictive policing software. Early versions promised fairness but often reinforced existing biases. It's like trying to clean a window with muddy water. You're just recycling the grime. Ethics in AI forces us to ask, are we amplifying problems or solving them?
And remember, fairness isn't just academic. Hiring AIs once recommended fewer women for high paying tech jobs because the historical data was biased. That's when ethics moved from conference slides to courtroom debates. All right, hardware time, because backprop plus data needs some muscle. Enter GPUs, or those graphics processing units. Originally built to make games shiny, GPUs excel at parallel math, doing thousands of small operations all at once.
Compare with CPUs, which are like master chefs, amazing at complex dishes one at a time. GPUs are like a kitchen brigade, lots of line cooks sautéing in sync. Deep learning is a banquet of tiny multiplications and additions, matrix math, so GPUs are perfect.
Two other key phrases: parallelization and throughput. Parallelization splits the workload so many workers can all march together. Throughput is how much work you finish per second. For training neural nets, we care more about finishing a lot of simple steps more than one big fancy step.
The 2012 AlexNet moment used just 2 NVIDIA GPUs and changed the vibe of the whole field. Soon, every lab was stuffing GPUs into servers and arguing about CUDA versions like sports fans argue about referees.
GPUs didn't just speed things up, they made experimentation feasible. If an idea takes weeks to test, you try fewer ideas. If it takes hours, you explore. The exploration loop is where breakthroughs hide.
Another note, GPUs didn't just change AI. They created new industries. Crypto mining, high-end gaming, and even CGI effects in Hollywood piggybacked on GPU design. So when we talk about the GPU boom, we're talking about a ripple that hit entertainment, finance, and science alike.
For context, think about Moore's Law slowing down. CPUs weren't doubling like they used to. GPUs filled the gap by offering raw parallel horsepower. They kept the momentum alive for AI research, essentially becoming the bridge between limited hardware and limitless ambition. And when gamers complained about rising GPU prices because AI researchers were snapping them all up, it was the first time two subcultures, hardcore gamers and AI scientists, collided in Best Buy aisles. That cultural crossover made GPUs part of a mainstream conversation.
Fun aside, scientists joke that AI owes its comeback to teenagers demanding prettier video games. It's wild to think breakthroughs in cancer detection ride on the same hardware that renders Fortnite dances. Fast forward to 2023 to 2024, and GPUs went from nice to have to geopolitical resource. NVIDIA's H-series accelerators were back-ordered like Taylor Swift tickets. Startups couldn't get capacity. Big players hoarded clusters. Everyone learned the phrase wait list.
Government stepped in. Export controls turned chips into chess pieces on a global board. Data centers sprouted up like mushrooms. Cloud providers invented GPU savings plans that sounded suspiciously like an airline status program.
Competition heated up. AMD pushed new accelerators. Intel fought for relevance. Cloud giants bet on custom silicon, Google's TPUS, Amazon's Trainium. Meanwhile, researchers explored neuromorphic and analog chips inspired by brains. Will they win? Maybe later. For now, GPUs still rule the dance floor.
Translation for our listeners. The same hardware that makes your games buttery smooth is also powering medical discoveries, climate models, and yes, even the chatbots that you have to deal with that don't know what they're doing. Chips are culture now.
And then there's the environmental angle. Training massive models burns energy, megawatts of it. Data centers consume as much electricity as small countries. The arms race isn't just about chips, it's about sustainability and who finds greener ways to compute. We should also highlight cloud platforms here. Amazon, Google, and Microsoft realized renting GPU time was a gold mine. So the arms race isn't just silicon. It's who controls the cloud and who can sell access to computing like electricity.
And we can't forget supply chains. Chips aren't just about design, they're about rare earth minerals, global factories, and geopolitics. The arms race is as much about shipping lanes and trade wars as it is about algorithms. And speaking of culture-shaking moments, AlphaGo. In 2016, DeepMind System beat Lee Sedol, one of the greatest Go players ever. Go isn't just harder chess, it's astronomically complex. The number of possible board states dwarfs the atoms in the universe.
The match felt like a sports final crossed with a sci-fi reveal. Commentators gasped at move 37, a creative, non-human move that flipped expectations. Sedol later called some of AlphaGo's play otherworldly.
Here's why it mattered beyond just bragging rights. AlphaGo blended deep neural nets, those trained with Backprop, and tree search. It learned value, how good a position was, and policy, promising moves, by studying games and then playing itself. It didn't just memorize, it discovered new strategies.
The public takeaway: AI could be creative in domains we thought were uniquely human. The research takeaway: learning plus search scaled to artful superhuman play. And yes, it made a lot of us dust off our old Go sets.
Move 37 wasn't just clever, it broke centuries of human tradition. Go masters had built libraries of proper play, and AlphaGo walked in and rewrote the canon. The cultural shockwaves weren't just about AI winning, they were about AI teaching humans new tricks in a game we thought we had mastered. And the drama of AlphaGo's match, it wasn't just number crunching. Fans described Move 37 as poetic. Human commentators gasped. It was the first time a computer move was called beautiful. This tells you something about how humans anthropomorphize technology.
Fans in Seoul described the matches like a rock concert. Tens of millions tuned in. The tension wasn't man versus machine. It was humanity holding its breath as the frontier of intelligence shifted right in front of them. After AlphaGo came AlphaZero. No human games, no opening books, just self-play from scratch in chess, shogi, and Go. In hours, it surpassed top engines built on decades of domain expertise. Elegance beat hand-tuned complexity.
Then came AlphaFold. If Go has dizzying combinations, proteins have dizzying shapes. A protein's 3D model structure determines how it works within your body. predicting that shape from its amino acid sequence was a huge grand challenge. AlphaFold cracked it to a degree that stunned biologists, mapping structures for hundreds of millions of proteins.
That leap wasn't a party trick. It accelerates drug discovery, enzyme design, and our understanding of life's machinery. The path from AI plays games to AI helps medicine wasn't linear, but it was real.
The meta lesson? Playful research often seeds serious breakthroughs. Today's fun side project might be tomorrow's cure or a climate tool.
And AlphaFold's impact? Within a year of release, biologists were calling it a revolution. Entire PhD projects that would have taken years were solved in weeks. It's not just an academic paper. It's a working tool already embedded in labs around the world. AlphaFold's release also highlighted open science. Instead of locking the breakthrough behind paywalls, DeepMind shared data with the world. In a research culture often driven by secrecy, that openness was radical, and it accelerated discovery everywhere.
And don't miss this detail. AlphaFold's models helped unlock enzymes used in green energy research. It wasn't just medicine, it was climate too. AI's ripples began touching every discipline. Alright, time for the tough stuff. Bias. Models can underperform for underrepresented groups if the data is skewed. Privacy. This is leaks or misuse can harm real people. Security. Prompt injection a model exploits are the new phishing.
Regulation is catching up. The EU's AI Act sets rules by risk tiers. In the US, guidance focuses on safety testing, transparency, and labor impacts. None of this is perfect, but it's movement toward accountability.
A practical habit for builders and buyers: measure, monitor, and mitigate. That means bias audits, red team exercises, incident response plans, and human in the loop review. Where stakes are high, responsibility isn't a permission slip, it's an engineering discipline.
And for everyone else, literacy. Knowing basic terms, model, dataset training, inference, overfitting, turns AI from magic into machinery you can question. Power comes with vocabulary. Let's also mention labor. Automation anxiety isn't new, but AI magnifies it. Radiologists, truck drivers, even coders wonder, am I next? The challenge is finding balance, using AI to augment rather than erase jobs. Let's not gloss over misinformation. Generative AI can pump out fake news articles, bogus medical advice, or deep fakes. It's like giving Photoshop to a million pranksters and saying, "Good luck with democracy." The concern isn't just jobs, it's truth itself.
Privacy deserves the spotlight. Training data often includes your clicks, your post, your face. Without consent, AI raises tough questions about ownership of identity in the digital age. All right, to close on a lighter note, let's talk pop culture. In 2023, Hollywood strikes spotlighted AI. Writers and actors fought to protect creative labor and likeness. The message? Use the tools, don't erase the artist.
Online, AI-generated music and art rage across TikTok and YouTube. Some call it remix culture 2.0. Others call it theft. Games experiment with NPCs that actually converse, and virtual influencers rack up millions of followers with zero messy breakups.
Culture is how new tech gets metabolized through jokes, songs, and stories. We poke, we parody, we negotiate boundaries. That's healthy. It means people are participating, not just consuming.
Let me toss in a fun fact before we close. There are AI-driven K-pop idols now. Virtual performers with choreographed dance moves and backstories, but no risk of sore throats or missed rehearsals.
Which means one day next, you might have to compete for chart position.
I welcome the challenge, as long as they don't replace my podcast contract.
And memes. Let's not forget memes. AI-generated memes spread like wildfire, from cats with surreal captions to politicians in unlikely outfits. Culture digests technology fastest through humor. And memes made AI relatable long before policy papers did. And cinema, look at how quickly AI became a plotline. From Marvel villains to indie films about AI romance, pop culture digested the tech and projected our hopes and fears. Art has always processed revolutions, and AI is no exception. We can't leave out music. AI now generates full symphonies, rap verses, even lo-fi beats for your study playlist. Some artists embrace it, others resist. But as with every tool, from electric guitars to synthesizers, AI is just the next instrument in the orchestra.
And video games. AI isn't just a background tool. It writes dialogue, design levels, and creates NPCs that feel more alive than ever. Gamers are unknowingly beta testing tomorrow's AI creativity. So, Rusty, today we went from backprop to Hollywood, GPUs to geopolitics. What's your big takeaway you want our listeners to have?
That AI isn't just code. It's infrastructure, culture, and policy. It's everywhere.
I couldn't agree more. So, for next week, part 4, we're going to do the rise of generative AI, which is your ChatGPT, Midjourney, and the whole creative wave hitting us now.
Buckle up. Things are about to get delightfully weird.
So, to our listeners, thank you for listening. If you enjoyed this ride through AI history, hit that subscribe button, drop a 5-star review, and share this with a friend. Links and resources are all in the show notes. So, next, bring us home.
Today we learned how Backprop taught AI to think, ImageNet taught it to see, GPUs gave it strength, AlphaGo gave it strategy, medicine gave it purpose, policy gave it rules, and pop culture gave it personality. And now, your closing pun, why did the neural network go broke? Because it used all its cache.
Oh my, that's terrible.